Okay, in this video, I'm going to show you how to do a problem like this, which I think you actually can't see super well because of this glare, but there it is. This is straight out of the notes that we got during class, and it's basically finding values of a and b so that a function is piecewise function like this is continuous. Later, we'll be doing differentiable, but in this case, we're just going to do continuous. So going back to my last video where I defined what continuity, the conditions are, you have to have the limit from the left equaling the limit from the right at a certain point, and also equaling what the value of the function is at that point. So if you recall, then that would be if the limit as x approaches c from the left of some value of some function equals that same thing from the right, and it also equals what the function is at that point. Hopefully you can see all this. Alright, but in this video, knowing that already, we're going to use that in application to solve a problem like this. So once again, I'm sorry for the glare, it's just kind of how it's working out right now, but as you can see, there are kind of 2 points to check in this one because the conditions are x is less than or equal to -2, and then here we -2 to 3, and then is greater than or equal to 3. So there are 2 points in this problem where you are going to want to make sure that's continuous. So therefore, make this piecewise function continuous. The first one we're going to check is a -2. So, following what we did before, I'm just going to write this down. I don't know if you'll be able to see it while I'm writing it, but we're going to do the limit as x approaches -2 from the left of g of x. And then we're going to do the same thing from the right. And then this also has to equal what the value is at that point. Now, because this is less than or equal to, this is going to be the same as one of these two. So we're going to be able to cross it out later, but for right now, just this is the basic setup, testing for continuity. So the left side, which would be the less than or equal to 2, would be the -5x plus 6. However, because we're plugging in -2, it would just be -5 times -2 plus 6. And this equals from the right, which would be this one, because this is for when it's -2 to 3, so this would be from the right side, and that would be a times 2, -2, I apologize, squared plus b times -2. And then this will equal what the value actually is, which would just be this top one. So we're going to then write the same thing that we wrote before in. Now, because these two are the exact same thing, you don't have to write this again, but just end a test, you're going to have to make sure your teacher knows that you check for that. So this would be 10 plus 6 equals 4a minus 2b, which equals 16. And this is the first line that we're going to have, and we're going to have to do a system by now checking the other one to get the other part of this. So let me erase this. Go back in the video and pause if you want to see that again, but now we're going to be checking the limit at 3, so we can get another line and do a system. So the limit as x approaches 3 from the left equals the limit as x approaches 3 from the right, which equals f of 3. Same test, we're just checking for continuity by doing this. So from the left, it would be this one, because it's for less than 3, and so this would be a times 3 squared plus 3b equals, and then from the right, which would be the second one, which is x cubed minus 2x. So it would be 3 cubed minus 2 times 3, and this will equal what it actually is, and because this function is less or greater than or equal to, it would just be this same second one, which once again you're not going to have to keep writing every time, but for the first setup you're going to have to write that. So you get 9a plus 3b equals 27 minus 6, which is 21. And then you can actually divide this whole thing by 3 and get 3a plus b equals 7, which is your second function that you're going to do the system with. So now that we have these two, it's simple algebra 1 system to solve for a and b. So 4a minus 2b equals 16. I'm going to do the one, I don't know what it's called, but it's the one where you add the two together. So multiplying the second one by 2, which hopefully you can see, this is just the function that we got. Multiplying the second one by 2, we'll then get 6a plus 2b equals 14. And by adding these together, you get 10a equals 30, a equals 3. And then plug that in, and you'll get 4 times a, which is 12, minus 2b equals 16. You subtract here, you get negative 2b equals negative 4. Or I'm sorry, that's positive 4. And b equals negative 2. So by using the definition of continuity, we were able to solve for a and b.